CPD webinar series in which we will cover the topics of how to model existing drainage systems and flood mapping with XP Swim. My name is Peter Coombs, and first of all I would like to introduce you to two of my colleagues who will be actively participating in this webinar with me today. Firstly, Ludmila Fedeva. Ludmila is a drainage engineer with 8 years of both design and modelling experience in the UK as well as overseas, specifically in the Middle East. Samer Mohandes. Samer has recently finished his Masters in Civil Engineering at the University of Greenwich after he did his undergraduate degree in Syria and worked in Cairo as a construction site supervisor. Welcome to you both. So here's the agenda for this 1 hour webinar. The actual demonstration and presentation takes about 35-40 minutes, but we've added in an allowance for the questions into this. So a maximum of a 1 hour webinar for you. And this is the first in a series of 7 that we will be running. First of all, I plan to introduce the purpose of why we, as engineers, need to model and map flooding. And I'll be highlighting some of the latest legislation, the standards and guidance that is currently available. Ludmila and Samer will then run a live demonstration using XP Swim to illustrate best working practice. The live demo will show how quickly you can build an accurate model of a local catchment. During this exercise, we will be importing a range of third-party data, and this can include LiDAR data as a ground model, existing water courses on the surface, existing drainage networks below the ground, as well as a proposed drainage system that's been designed in micro-drainage software. When the model has been built, we will then apply a grid across this catchment and apply rainfall directly falling onto the grid. This will generate runoff. So that's the idea of the webinar. Now looking at the legislation. There's a range of legislation covering Europe, Middle East and Africa. In Europe, for example, the EU Floods Directive is on the assessment and management of flood risks, and this came into force on the 26th of November in 2007. The directive requires all member states to assess if all their watercourses and coastlines are at risk from flooding. They need to map out the flood extents, the assets, and also the humans at risk in those areas, and to take adequate and coordinated measures to reduce this flood risk. With this directive, it also enforces the rights of the public to access this information and to have a say in future planning processes. In the Middle East, we have a range of national visions, and for example, in Qatar there is a national vision defining the long-term outcomes for the country, and it provides a framework within which national strategies and implementation plans can be developed. By 2030, Qatar aims to be an advanced society capable of sustaining its development and providing a high standard of living for all of its people. Now this takes into account 4 key pillars, and those pillars are economics, their society, humanity, as well as the environment, equally important to one another. Now flooding and climate change are seen as one of the key threats to this vision not being implemented. If we look now at the European legislation, the EU Floods Directive includes a complete timetable of key requirements as well as milestones along the road, and this is what you can see with the slide here now. The directive has been transposed down into local legislation covering the whole of the continent, and for example, the flood risk regulations came out in 2009 and the Flood and Water Management Act came out in 2010 covering England and Wales. Similar implementation of local legislation has happened everywhere, Scotland, etc., and across Europe. Therefore, by law, we need to deliver, and this is by law. At the moment, we, and when I say we, I'm referring to DEFRA, the Environment Agency, SEPA in Scotland, and the lead local flood authorities, they have already delivered key components of this plan. The preliminary flood risk assessments were completed in December of 2011. The flood hazard and risk maps were completed and submitted to Europe in December of last year, 2013. And currently, we are now working on the deadline to provide flood risk management plans, or FRMPs, by December of 2015. Now these will include detailed plans on items such as evacuation routes. Looking at the guidance and standards, there's a wealth of detailed guidance, documents and standards currently available. During the course of this series, we will be demonstrating their application, and we will provide you with a completely systematic approach to your modelling projects. So this will enable you to deliver such requirements in both a timely as well as a compliant manner. When we create a surface model, this will help us to provide the first level of assessment, flood assessment. We'll create a base for further work by bringing in surface modeling information. And this will then provide a strategic assessment. This first level is known as a strategic assessment to identify those areas of most risk to flooding. When we start to hone in on the priority areas, those areas that are deemed to be at highest risk, then we can provide a second level or intermediate assessment. When we further look in detail and identify the causes and consequences of flooding, this will constitute the third level, the detailed assessment. This is all covered in best practice guides, and we can refer to these guides during the course of the live demonstration, such as Table 3.2 of DEFRA's Surface Water Management Plan Technical Guidance document. Is shown on the right-hand side of the screen here now. This was published in March 2010, but we've been doing this work for decades. It's important at this stage to realize that there are a number of sources of data available, as well as a range of stakeholders that we must satisfy, including the public. So to create an accurate representation of localized flooding within XP Swim will enable extremely complex situations to be very clearly illustrated, and a range of outputs will be provided to satisfy your local requirements wherever you're listening from. So we have choices and we have consequences should we continue to fail. And we have failed pretty well globally. So nobody has got this right yet, hence the need for us to carry out all of these surface water management plans and flood risk assessments around the globe. What does failure affect, though? It affects economics, the economic development of countries. It affects society, and it also affects the environment. So these are some of those pillars that I mentioned earlier on. Flooding, combined with the predictions on future climate change, are threats that are actually on the increase. These are not diminishing, these are increasing. So we need to work together to create great places to live, not just for ourselves today, but as for the future generations to come in the future. And the vision's there, whether it's legislation in Europe or whether it's the visionary documents for each of the countries in the Middle East. We have the Global Sustainability Assessment System that you can see here. And what we're trying to do is not just look at flooding in isolation. What we plan to do is to provide multiple benefits to both society as well as the environment. So when we put in mitigation measures, we're providing those multiple benefits. Well, I think that's enough of an introduction from me. It is now my pleasure to hand you over to Ludmila and Samer. Initially Ludmila, who is going to explain what she's going to cover with Samer during the live demo. We will illustrate the importation of third-party data and create a model. So without further ado, over to you, Ludmila.
Thank you, Peter. Welcome everyone to our webinar today. Before starting the demonstration, I would like to say a few words about the site. Originally, the site used to be a green field with a watercourse, which was typically dry, crossing from southwest to north direction, as shown on a slide by blue arrows. The site had few ponds, which are shown by red arrows, And over a period of time, say 50 years, our site got built up and now it looks like this. So the water course was partially converted as identified by a red oval in the middle, and three number of ponds were dried up and built up. So if we go one step back, we can see the ponds are here, and on the next slide there are buildings. Around 100 properties were constructed on our site. So by the end of today's webinar, you will see how fast and easy it is to build up a model and do initial high-level hydrology analysis, such as applying grain on grid. This water depth map, which is shown on the slide, demonstrates natural water flow paths and detention areas after the rainfall was directly applied on the grid. Now I'm going to hand you over to Summer, who will start the demonstration.
Thank you, Ludmila. Thank you, Peter. Good afternoon, ladies and gentlemen. Lovely to have you all here today. We're going to start with a blank project and specify the units. And here we will choose metric units. And I will now introduce you to XP Swim interface. If we look at the left-hand side of the screen, we can see the layers control. And from here we can build our model and import our elements like background image, CAD files, GIS files, topography, 1D network elements, and 2D model elements. And finally, we can view our results, our 1D results and our 2D results. And if you look at your right-hand side, we will have XP tools. And from here, we can draw our network, which might be river, drainage network, catchments, storage nodes, or flow controls. It has also some other useful tools to measure lengths, slopes, and areas like this. So we can have a polygon and measure the area and the length and the slope. And we have another tool to have cross sections in different parts of the model. As a first step in modeling, we have to start with representing our area or our site, which will be modeled. We have different options to represent the area. It could be background image, it could be CAD files, or it could be both. In this example, I'm going to import a background image to represent the site and a CAD file to detect the pipes and manholes locations. So I'm going to right-click on background image from the layers control and import the background image which will represent the area. And in the same manner, I'm going to import the CAD file which will tell me where are our pipes, links, rivers, and manholes. So if I turn off the background image, it will be more obvious to you. So these lines and circles, they represent the locations for the pipes and manholes. We have an option to convert them to real river, real links, and nodes. And when I say nodes, I mean either manholes or open junction. So all we have to do is to tell the software which is which. So we will easily say these are my links and manholes, and here we go. We have our model ready. However, I'm going to delete everything because I want to show you different methods in importing the network. So if we delete that, before we start modeling, we have to notice one thing, that this site here considered in this software as a flat site, as there is no topography described here. So we have to describe the topography of the area, and we can do that from layers control. If I right click on DTM, digital terrain model, we can create the DTM from XYZ files, from ASRI grid files, or from ASCII raster files. So we will do that from XYZ files. Normally these data, XYZ data, are included in text files or Excel files, and we usually get them from the LiDAR. So I will use a text file to get the levels. And here we go. We got our topography described here. And if we look at the bottom of the screen, we can see X, Y, Z data are shown for each point of the site. However, we don't prefer to see this like height map, field color height map like this. So we prefer to see contour lines, which will be more familiar and which will give us better representation. So we can play with the display settings to show the contour lines. And now we have contour lines which will be more familiar to us. So we have an option to view the legend. So we can see from here that like the range is between 36 meter to 75 meter, the height range in this site. And now with XP Swim, we can either draw our pipes, rivers, and manholes manually from XP Tools, or we can import them from shapefiles, database files, or MDX files, which are the files produced by microdrainage software. I'm going now to import the nodes from shapefile, and then I will import the links and rivers and pipes from database file. So if I right click on nodes, I can import a shapefile. Here we go. We have now our nodes ready, and I will import the links from database file. And here we have the option of telling the software which is which. And we have the option of telling the software what data we want to import with these links. So if I need to import the length, the slopes, the roughness, I can do this, and we will see that in a minute. So here I want to import the length of these links, the slopes, and the roughness. And when I say roughness, I mean manning. And of course, we need the link name. So if we say finish, import, we got all these data ready for us. And now we have our watercourse modeled and ready. And if we double click on any of these links, let's say that we can see that our manning factor, our lengths, our slopes, they got imported as well. And now I will hand you over to my colleague Ludmila. She will show you how we can import our drainage network, which will be connected to this watercourse. Over to you, Ludmila.
Thank you, Samar. Now, when we do have some portion of data imported, I'm going to demonstrate you how to bring in a micro drainage network, MDX file. I would click File, Import Data, Import MDX data. Then I will just choose an MDX file I would like to import and press Open. And as you can see, a portion of drainage network has been imported. Now, what we would like to see if all the data which we have designed in microdrainage has been transferred into XP Swim. So I'm going to check a manhole. So we can see that the manhole invert level and manhole cover level has been transferred over from XP Swim. Similarly with the pipe, if we check the diameter, slope, mannings, upstream invert, downstream invert, ground levels, all has been converted from MDX file into XP Swim model. The other thing which is very important when we bring over MDX file is the areas. So if we go to runoff mode and check the contribution areas, we can see that all the areas which were specified in micro drainage has been transferred over. So all my contributing hectares are in the model now. Same time, if we do have a rainfall event which is ready in micro drainage and we can export it as a regex file, we can easily import it into XP Swim. So we can just load rainfall data, regex file, and we can import our regex file and reuse it in XP Swim model. So I will press OK. Now, when we do have a drainage network and we do have some links and nodes for the river, what I would like to do, I would like to identify the extents of my river. So I will switch on the background image so I can see where my river starts and where it transfers to a pipe. So I will select all these links and nodes. I will right click on the river and convert selected links to a river. I will give a river a name. It will be River 1. And here it is. We do have a river. So the river link looks differently from a pipe link. A pipe link is just a line, but a river link has a dotted lines along the black line in the middle. So if we double click on a river link, we can see that it looks different from a pipe link. This was the node. Okay, this is the link, right? It looks different. It represents the open section. So in here, we do have options to edit the section. Either we can create a section ourselves and edit it manually, typing in the data, or we can copy over the data from Excel. We can identify left over bank, central channel, and right over bank Manning's values. Or if we do have a Manning which is changing over the depth of the river, we can put in a variable Manning depending on the depth of the water. So say if you do have a river with trees growing over bank or with some special conditions, you can identify it all here by changing the roughness. Same time, we do have an option of bringing in Hecras cross-section. If you do have a Hecras cross-section, you can easily bring in a Hecras cross-section. So I do have a first part of the river identified. So now I'm going to identify the second part of the river by repeating my actions. I will convert selected links to a river, give it a name again. It will be River 2. And I do have a second part converted. So now, what do we have here? On our side, we do have a road which is crossing the river. So in this case, I would like to make it a bridge. I would like this road crossing to be a bridge. So I would select a link which I'm interested in converting into a bridge, right click and select bridge link. So the bridge link looks very similar to a river link, but it has two parallel lines in the middle, which are perpendicular to the link itself. So if we double click on a river link, we can see that it looks slightly different. We do have a section which represents a bridge. We can edit such data as chord elevation, low and high, skew angle, weir coefficient. Weir coefficient means when the water level reaches the road and the road starts acting as a weir, we can have a weir coefficient for it. Similarly, we can edit the hydraulic section for the bridge. We can identify the section and then we can have different type of openings in here. We can have either bridge which is which helps now us to identify the piers. We can edit some data in here, or we can have culvert. So I do have a slide prepared with some rated data. So in here I do have a bridge section, hydraulic section already entered. I do have a couple of piers, and I do have a circular bypass. Right, so now I will explain how I did it. So if I select culvert, I can say, if I have a bypass which is circular, I can just pick a circular, and we can identify all the physical parameters of our circular bypass. If we do have a rectangular section, and say our bridge consists of 3 rectangular sections in a row, we can just here in the openings have 3 culverts. Each of them would be a rectangular culvert, and we'll specify the sizes and the criteria. If we do have, say, an arc bridge, which is very common, we can just use a user-defined section and define our section manually based on actual bridge parameters. Right? And same time, if we do have a bridge which has piers, we can just add piers and pier coordinates, pier width, and so on. So now, when we do have a bridge, I just want to double check if all the model is built. So I will switch back on my CAD file, and I will see that we have a small piece missing, which was not covered by any of our imports. What I will do, I will draw it manually. I will pick a link, and I will just draw it on top of my background CAD data. So now I do have a missing part connected to my network. Obviously, when we draw something new, it has a default criteria. So say there is no ground level, no invert level. The default length is there is no diameter, it's not actual, right? So we will need to enter this data manually, or we can import this data through XP tables. There is a special tool called XP tables where you can copy big amounts of data in, but we will not cover how to use them today. We will do it next time. Now I will hand over you to Summer, and Summer will demonstrate you how easy it is to do a preliminary flood risk assessment by applying grain on grid in order to identify ponding areas and flow paths.
Thank you, Ludmila. Here we are. We have everything ready and modeled. And now we are interested in making it rain on our site to see which directions will the water be flowing to and where will it be accumulating or ponding. All we have to do is we have to use 2D elements and draw a grid on our site. And we will need another grid. It's called rainfall grid. So basically, we will tell the software that we want this particular rainfall storm to be landing on this part of the site. And we can adjust the grid cells from the properties. So we tend to have small cells when we are working in urbanized and undulating areas where there are lots of changes in the topography, and we tend to have big cells when we're working in rural flat areas. But it's not good to have small cells for all the site because the runtime will be increased enormously. And at the same time, if we use big cells for all the site, we will have a not accurate model. Before running the model, I'm going to turn off these grids and show you the topography of the area again. And we can notice that at the bottom right side of the site, there is a hill. So the water will be shed from the highland to the lowland into the depression area on the left-hand side, where the water will be accumulating. Now when we run the model, we will combine these contour lines with the water depth map, and we can see that is the water will be acting according to the topography of the area or not. And now I will run the model, and during the running time we will take some questions. Peter.
Thank you, Samir, and thank you for your questions, folks. Very interesting ones. So whilst this is running for a minute or two, I'll just pitch across a few of the most common questions that have come in from everybody. First question is, if there's no watercourse information like we were importing from the database there, or HECRAS, if we don't have that detailed information on the watercourse, but just the LiDAR data, like a ground model, would it be possible to create sort of cross-sections of a watercourse based on a ground model?
Thank you. Very good question. Yes, we can do that. We can use the LiDAR data to generate the cross-sections for the watercourse. It's possible, and I will show you that after the runtime.
Thank you, Samir. And just to remind you, folks, what we'll do, the questions that have come up during the webinar, we'll do a question and an answer sheet, a fact sheet, and then we'll send this out to everybody as a follow-up. The next question is, again, related to the river. What we've just done is applied a grid onto the catchment and then rainfall upon the grid. How about if you have like hydrograph information? Can you generate a hydrograph at the upstream end of the watercourse, for example, to generate flow in the 1D section?
Yes, we can generate a hydrograph at the upstream end. So all we have to do is to double click on the node and put the hydrograph information, which will be time versus flow.
Perfect. Thank you, Samir. I think we just got time for one more question. I think you've answered it already in the presentation there, but there was a query asking whether you can specify different grid cell sizes and have a mixture, if you like, upon one catchment.
Thank you. Very good question as well. Yes, we can have more than one grid. So as I said, we will use small cells when we're working in urbanized and undulating areas, and big cells when we're working in more flat and rural areas. So we can have, for this site, we can have more than one grid. And now we will check the water depth map. And we can see here, as we expected, that the water is acting accordingly to the topography of the area. We can notice that the water depth is not well presented here. So we can adjust the display settings and tell the software we're not interested in any water depth less than 10 centimeters. So we can go to properties and restrict the display range. And now we will have better representation of the water depth. We can use the cross-section tool to view some cross-sections. So from this cross-section tool, if we view cross-section for the river, here we can see that the river, before we run the analysis, was a dry river and it was acting like a wadi. But after the rainfall storm, the stormwater contributed in this river, and now maybe it will be flooded again out of the river. And this is called 1D, 2D integrated model. The 1D part of the model is the river, and the 2D is the 2D model, our cells. And now, from the layers control, from 2D results section, we can generate different maps required for the environment agency, like the water depth, water elevation, velocity, hazard maps, and flow direction maps. All these maps, they look really good, especially when the bus is coming, so you can make your screen look as busy as you want. And all of these maps are required when you want to submit a model to the environment agency. Well, this is the end of my part of this webinar today. I want to thank you very much for listening and allocating your time to attend this webinar, and I will hand you over to my colleagues, Ludmila and Peter. Enjoy the rest of your day wherever you are, and see you next month. Over to you, Ludmila.
Thank you, Summer. So now when we finished the first part, which was importing the data, and you could see what various types of data we can import, I would like to cover our next webinar schedule. Our next webinar will be on 22nd of September, and it will be on river stream modeling. It will be focused on river stream modeling, where we will cover such topics as generation data for flood risk assessments, culvert blockage modeling, estimating river freeboard levels, river level change modeling, detailed bridge modeling, inflow hydrograph, import, generating river section for digital terrain data. So coming back to our questions, if we can generate a river section out of digital terrain data, yes we can, and we will show you in our next webinar how to do it. Peter?
Great. Thank you, Summer. Thank you, Ludmila. I'm just going to take a few more questions. So if we've got a lot that have come in here, if we can scroll up towards the top. There is a question about importing data into micro drainage, and just reading the question here, just going through them all. Right, can we import a large amount of information from, for example, Excel file into the network details within micro drainage, or Windows as it used to be now, in one go? That's one thing that we shy away from. The reason is the micro drainage software is a design software. So the micro drainage is a design software, and what we know is how micro drainage works and gives you the correct answer. What we don't know is whether someone's done something correct in Excel. So we don't like importation of that kind of information into micro drainage. You can definitely import that into XP Swim because it's a modeling software. So that's the difference between the two suites of software, and why we use XP Swim for modeling and we use the micro drainage for design. The other questions, there's the input hydrograph, and also if you have a water course catchment over a large area of a few square kilometers, and if your site is just one small part of that massive catchment, could XP Swim take into account the two catchments for the water course on the one hand and for the site on the other? So I'll hand you over to Ludmila, who's going to answer that question for you.
Yeah, we can do different boundary conditions. And so if you have a small site and you have another catchment around it and you are not ready to model the whole area, you can just import boundary conditions. So you can identify boundary conditions around your area of interest and model it this way.
Yeah, that's good. Another question is, could we sample the output reports and the figures? This is something that we're going to cover in future webinars, but I'd also encourage you to take a look at the website, or maybe we'll send out a link to you following this webinar to enable you to download a free version of XP Viewer. So this will enable you to download the software. Pretty well everything that Ludmila and Summer have shown you today you can do, and we can send you some sample files as well to get your hands-on experience with. But you won't just be able to save the information. So I'll send out a link on that one to help and enable people to participate with the software remotely. So thank you all very much for your participation. We're just getting the hurry up sign here, so we're going to have to close the webinar now with a few comments and conclusions, and then get everything prepared, ready for the next one. So thank you, Ludmila, and thank you, Summer, for showing us a really insightful introduction and taking us through this first step of providing a systematic approach to our modeling projects. I hope everyone out there really appreciates now how we can import a complete variety and range of data using a lot of different third-party software outputs, and how easy it is to create a fully integrated 1D, 2D model. More information and how we do this in detail will be coming over the subsequent 6 webinars. And also how quickly we can actually run this strategic assessment just to identify those areas at most risk to flooding in fairly short order. And also the fact that those outputs are all EA approved in the UK, for example. Just to reinforce the message that Ludmila put out there, that the next webinar we've planned for Monday, so rather than a Wednesday, we're going for Monday, the 22nd of September. It'll be the same time, 12 p.m. British Summer Time, so it'll be 2 p.m. in Saudi, etc. And please note that we're also running XP Swim training. So there's a training series of 4 days, and this will be run from the 29th of September, a week after the next webinar, so I can remind people then, up until the 2nd of October. And that training is taking place here in the Newbury Training Centre. Details will be posted up on the website too. So just to confirm and reassure you that we will be uploading a video of this webinar onto the website. We will produce a frequently asked question fact sheet and send out a very brief survey monkey to get your feedback, which would be much appreciated. Maybe 30 seconds to do the survey monkey to check that it was relevant, etc. And do feel free to email us with any particular topics that you'd like us to cover in future ones, because we can build those into the series. This survey monkey, by the way, will enable you to also request, just tick a box and drop your email in so that we can send out a CPD certificate to you for attending this particular event. So thank you all for attending. We really appreciate your active participation and all of the questions, and we're looking forward to keeping in touch and meeting you again online at the next event on Monday, 22nd of September.